Okay, so let me get back to where I was at. Okay, so we're going to have four main functions. They are called the parent functions. And what's going to happen with these parent functions, they're going to be graphs, four very common graphs, and you are going to have to memorize what they look like, okay? And you're going to think, oh my gosh, it's not going to be that bad, okay? Once you see them, you've probably actually seen them before. So you're going to have to know what they look like. And so the goal of this section is for me to write a function. Let's say I write it like this, whatever, there's the function. You need to automatically in your mind say, oh, it's going to look something like this. That's the goal. And so I'm going to go through and we're going to graph each parent function. There's just four of them. It won't take us that long to do. And then we're going to talk about how we're going to manipulate them. We're going to make them bigger, make them smaller, flip them upside down, maybe move them to the left, move them to the right, things like that. So the first one that we're going to look at, the first parent function, and we talked a little bit about this yesterday, is simply the basic quadratic function. Quadratic function, which is f of x equals x squared. This is the most basic parabola, okay? We very quickly discussed this yesterday. And what we're going to have to do is we're going to go back to our old school days where we made an x and y chart. And we want to know, we know from yesterday that, and I'm going to erase this very quickly, but we know that it's going to look something like this because we did that yesterday. But we want to know exactly what it's going to look like, okay? And so what's going to happen is we're going to make this x and y chart. And we also know that from yesterday, x squared, that its vertex is the center, 0, 0. And so I don't have to do any work for that. I can just pop that right in there, right into my x and y chart. Now, I also mentioned yesterday, when we're graphing functions, we want to know what's happening close to the origin. I don't really care what's happening way over here or way over here. That doesn't really help me. And so when I make my x and y chart, what I want to do is I want to pick numbers that are close to the origin, close to the vertex. And so for this particular problem, I'm going to pick -2, -1, 0, because I already know it's going to be 0, 0, and then 1 and +2. And so what's going to happen is that's going to allow me to have a glance of about right through here to see what's happening with my function. And I need to know that. And so here I go. All I'm going to have to do in order to fill out this chart is to take these x values and put them into this 1x that I'm given. That's it. Okay, so I'm probably going to erase this graph. I'll come back to it in a moment. So what I'm going to do is I'm going to say, okay, well, I'm going to take -2 and I'm going to square it. What do I get when I square -2? +4. Then I'm going to take -1 and I'm going to square it. What do I get when I square -1? Well, +1. If I didn't remember that the vertex was 0, I could square 0 and of course get 0. And then I'm going to take +1 and square it and get +1. And then I'm going to take +2 and square it and get +4. And so now, once I do that, these little guys right here are actually ordered pairs. These are the points that I'm going to graph. And so we've already discussed how the point 0, 0 is the vertex. That's not going to change. Oops, vertex. And so what I'm going to do is I'm going to come over here and I'm going to make a graph and I'm going to plot these points. And so here's my graph. 1, 2, 3, 4. And if you happen to be looking at the notes, you're going to see that when I drew my graph, I actually used graph paper because it was much easier. And so I'm going to start by graphing this guy. So -2, 4. So left 2, up 4. So that's going to give me this point. And then -1, 1. Left 1, up 1. And then, of course, my vertex, 0, 0. And then right 1, up 1. And then right 2, up 4. And so here is the most basic parabola of x squared. And this guy right here, this is the parent function. Here is what he actually looks like. In the red, you're going to want to know this stuff. If I tell you, hey, quickly, give me a rough draft of what x squared looks like, here's what I'm asking. Now, I don't want you to have to write all this stuff out every single time. That's way too much work. I want you to just know in your mind, hey, the vertex of x squared is always 0, 0. And from there, this is what it's going to look like. This is the first parent function. Any questions, any problems on this one? Okay, so then let's take a look at the second parent function that we're going to have to, be familiar with. So the second one is what we call the cubic function. And that's going to be written as f of x equals x to the 3rd power. And again, what we want to do eventually is we want to get this thing on a graph. Well, I don't really know what that looks like. We have never done this before. So what we are going to do is we're going to make our x and y chart. And pretty much every single time we're dealing with a parent function, we want to know what's happening right around the center. And so we're going to choose numbers that are really close to the center. So again, I'm going to choose -2, -1, 0, 1, and 2, just like I did on the last one. And so then, in order for me to actually calculate that, I'm going to take the number -2 and I'm going to cube it. And when I do that, I will get -8. I'm going to take the number -1 and I'm going to cube it, giving me -1. I will take the, oh my goodness. I will take the number 0 and I will cube it and I will get 0. And then I will take the number +1 and I will cube it and I will get 1. And then lastly, I'm going to take the number 2 and cube it, which of course will give me 8. And so now I can fill in my Y chart and I will have all of these points that I'm going to come over here and I'm going to graph. Okay, and so now that I have my points, I will graph these and we'll see what x to the third looks like. And so the first point is -2, -8. Well, I don't quite have 8, so all I know is it's going to be up here somewhere way up there. Okay, fine, good enough. I'm going to have the point -1, -1. So I'm going to, oh, wait a second. Oh my gosh, guys, I misspoke. Let me go back. The first one that I was plotting was this guy right here, -2, -8. I'm sorry. So I'm going to go left 2 and down 8. My bad. So somewhere down here. And then I'm going to plot the point -1, -1. So at the origin, I'm going to go left 1, down 1. And then, of course, I have the vertex, which is 0, 0. And then I have the point 1, +1. And then I have the point 2, 8. So up here somewhere. Now, here's what happens. Okay, don't write this. Just watch. I'm going to do it in red because then I'm going to erase it. A lot of people want to do something crazy like this, and they just want to, incorporate those three dots and say, don't care about you, don't care about you. I cannot do that. This is not a straight line. Okay, so what's going to happen is I have to make sure that in my mind, once we get this written down, we have to make sure that we always know what x to the third looks like. So here's what's going to happen. I want you to take your hands and stick them out in front of your face, palms away from you. Take your right hand and flip it. Take your left hand, and flip it down. Touch your thumbs together. That's what x to the third is going to look like. Okay, it's like you've taken a parabola and you've put half of it down. So when we draw the picture and I actually connect these dots, you're going to start at the origin. You're going to draw half of a parabola going up like that. And then you're going to go back to the origin and you're going to draw half of a parabola going down like that. This is the picture of what x to the third looks like. And so eventually, when we start talking about these functions and we start manipulating them, if I say, hey, draw me a quick graph of what x to the third looks like, this is what I need to see. You need to know that its vertex is 0, 0, and that it shoots up one way and shoots down the other way. So looking at this parent function, which is the cubic function, any questions, any problems on this one? Okay, so then let's take a look at the third parent function. All right, so this one, its name pretty much tells you exactly what it is. It is the square root function. And it is represented as f of x equals the square root of x. There's what it looks like. And so eventually what's going to happen is eventually I need to put it on this graph. Well, again, maybe we don't know what this looks like because technically we, as a class, we haven't studied this particular function. And so here's what I'm going to do. I'm going to choose my x and y chart. Now, you're going to notice on the left-hand side when I drew this graph, I drew it kind of wonky. Okay, typically I make it like a perfect cross, but here I made it a little skewed. Here's what I want you to think about for a minute. Way, way, way back, when we first started talking about square roots, did I let you take the square root of a negative number in the beginning?
No.
No. Okay. And so what's going to happen is we're going to have to revert back to that for a few minutes. When we are drawing a graph of a square root, and if it's just this guy, nothing else, there's not going to be any value over here because there's negative numbers. There's not going to be any value over here because there's negative numbers. There's also not going to be any value down here. So right here in this quadrant, that's the only place where a regular old square root is going to be. That's why I've drawn my graph so funny. And so having said that, the fact that we're not allowed to take the square root of a negative number, instead of me doing -2, -1, 0, 1, and 2, I need to pick numbers that I can easily take the square root of. And so if we start at the number 0, what is the first number that I can easily take the square root of? Well, it's 0. What's the second number that I can easily take the square root of? Just 1. What's the next number that's a perfect square? 4. and then 9, and then 16, and 25, and so on and so forth. Okay, but our graph is not 25 units long, so we're only going to probably go to, I don't know, let's just go to 9 because that'll be good enough. Okay, so here's what we're going to do. We're going to take our x's that we picked and we're going to pop them in right here. And so over here we're going to say, all right, well, what is the square root of 0? Well, it turns out that it's just 0. And so then I say, okay, well, what is the square root of 1? Well, it's just 1. And then I say, okay, well, what is the square root of 4? It's just 2. And what is the square root of 9? Well, that's just 3. And so now I have these nice, neat 4 points, these guys right here, that I'm going to come over here to my graph and I'm going to put them on there. Whoops. Oh, man. Sometimes me and Zoom, we fight a little bit. Okay. And so here's my graph. And again, I don't have to worry about anything over here. Nothing going on over there. And so I'm going to start plotting these points. So here I go. So the vertex, the first one I'm going to plot is 0, 0. So got that guy. And then I'm going to plot the point 1, 1. Okay, so it comes up a little bit. And then I'm going to plot the point 4, 2. So over 4, up 2. Okay. And then I'm going to plot the point 9, 3. So to the right 9. And then up 3. And then we had a 16 here. And if we would have had that, we would have had a 4. So we would go on over 16 and we would come up 4. Eventually, it's going to continue in this manner. I don't care about anything really past 9 because, again, my graphs aren't going to be that big. And so I'm not going to be able to see that. So once I have these 4 or 5 points drawn, I'm going to connect them with a slow, gradual curve like this. And so it's kind of like you've taken a parabola, you flipped it on its side, but then you got rid of the part that's down here. And so this guy right here, this is what my square root function looks like. And so in the future, when I say, hey, quickly, tell me what the square root function looks like, this is what I need you to tell me. Now, in the past, a couple of kids in my classes, they've said, oh, that looks like a dolphin jumping out of the water, which to me is kind of silly, but sometimes silly things stick in our head. So when we mention the square root function, this is what I'm talking about. So what are your thoughts, questions, problems, anything right now that we need to talk about as far as the square root function goes?
Oh, that's good.
All right, so then let's look at the last one, okay? The last parent function. This one is called the absolute value function. And we talked about absolute value a long time ago, absolute value function. And we know that absolute value on a number line is just the distance from 0. And we also know that the absolute value function is not going to be able to be negative, so to speak. And so the function itself looks like this. F of x equals the absolute value of x. And so what's going to happen is eventually I got to put this thing on a graph. Well, again, I don't know what it looks like. So I have to make some x and y charts. And since we're back to like a normal function, so to speak, we need to know what's happening right around here. And so again, in order for me to figure that out, I'm going to choose numbers that are right around the origin. So I'm going to choose -2, -1, 0, 1, and 2. And then in order for me to calculate this, I'm going to take these x values and put them right there. And so I will have the absolute value of -2. Well, what is the absolute value of -2? It's just 2. And then I'll take the absolute value of -1, excuse me. What is the absolute value of -1? Just +1. And then the absolute value of 0. And then the absolute value of +1. And then the absolute value of 2. And so
0, 1, 2.
Yep, 0, 1, and 2. Perfect. And so 0, 1, and 2. Okay, and so now I'm going to come over here to my graph. I have all these points that I need. And I will plot them, and we'll see what the absolute value of x looks like. So we'll plot the -2, 2 first, and then -1, 1. And then we've got the point 0, 0, which again is my vertex. And then I have the point +1, +1, and then the point +2, +2. Now, if I were to continue and I happen to choose the absolute value of -3, well, that would be a 3. And so this is going to continue one by one. It's going to continue going up in this fashion. Same thing with over here, a nice, neat straight line. And so when I connect these dots, I'm just going to get a V shape. And so yesterday when we talked about parabolas, we said it was a U shape. Well, today when we're talking about the absolute value function, it's a V shape. And we have to make sure that if we are drawing a picture of the absolute value, it's a nice, neat, straight V. And if we are drawing the picture of the parabola, it's a nice curved U. And so later in the future, when I'm asking you, hey, what's the absolute value function look like? This is what I need. Now, what are your thoughts? Those are our 4 parent functions. We're going to be using those a lot in the next two sections. We're going to be manipulating them, flipping them, making them wider, making them skinnier, moving them to the left, moving them to the right, all kinds of things. So what are your questions? What are your thoughts on these first four parent functions?
They seem pretty easy.
Yeah, it's not
Straightforward.
Has anybody ever studied what we call parent functions in the past? You ever heard that phrase?
Yeah.
Okay.
No.
Well, some haven't, some haven't. Okay, cool. All right, so we're going to dive into an example. And what I've done is I've gone through the Hawks homework so that I know exactly what they're going to ask you. And I've picked out some problems, and we're going to do them. And I'm going to tell you exactly what you would be typing into Hawks. Okay, that way it's kind of like a 2-in-1. We're studying, but we're also understanding how Hawks is going to want us to do things. So here's the first question. The example what you're going to get is H.
Your mic is kind of bugging out a little bit.
My mic is?
Or at least for me, it's like scratching around.
Yeah.
Kind of
It sounds
muffled.
like you're underwater.
Well, let me see if I can fix that. I tell you guys, I'm using the Surface Pro, which Fairmont State gave me several months ago, and I've been
That's
using it
better.
more in the past week than I ever have, so it's probably about to blow up on me.
Yeah.
All right. Thank you for telling me. Okay. If anything happens, just let me know. All right. So here we go. The function that we're going to be starting with is h of x, and we're going to say that is equal to -2 times this. Now, I notice I didn't say anything. Okay. Hawks is going to say, hey, look, here's your example. And the first thing they're going to ask you, step A, is they're going to ask you, what is the parent function? And so what's going to happen is you're going to have to be able to look at any given function and say, hey, it's either going to be the first one of the four. It's either going to be the quadratic x squared, the cubic x to the third, the square root, or the absolute value. So looking at just this, what's the parent function? What's the function that's going to be manipulated in this problem?
Absolute value.
Value of x. Excellent. Okay, now that's going to be the first thing. Then they're going to say, all right, real quick, just tell me what that should look like. And so what's going to happen is we have to take a look out front. Yesterday we talked about if there was a negative sign out front, how did our parabola open?
Down.
Yeah.
And so that applies to these parent functions. Since we see, really it's just this negative. Since we see a negative out there, we know that this particular function, whatever it happens to look like, is going to open down. Well, in your mind, okay, what you need to start doing is you need to be able to start conjuring up, generally speaking, this guy's the V, right? But you just told me because of this negative sign, it's going to be opening downward. And so in Hawks, they're going to show you a bunch of graphs, and they're going to say, hey, pick the graph that this guy, that this guy right here is going to look most like. And maybe they have graphs that look like this. Maybe they'll have a parabola. Maybe they'll have something that looks like this. I don't know. Somewhere along the line, though, is going to be a V that's facing down. And you're going to have to click on this guy. And it's not going to ask you for exact values or anything like that. It's just going to say, hey, what's the basic shape of this particular function? And so you're going to have to say, oh, well, the parent function is this. Typically, it looks like that. But because of this negative sign, now he's flipping down. And you're going to click on this guy who looks like that. So I know there's a lot of writing on the screen, so let me get rid of some of it. So what are your thoughts on looking at this particular function and saying, hey, I know that the function is the absolute value, but I also know because of this guy, the absolute value, which is a V, is flipped down. And then searching through I don't know the word I'm looking for, searching through some graphs and coming up with the answer. Can we do that? Was that too bad?
Seems doable.
Yeah, I think, and I mean, I really think it is. It's just you have to understand what these parent functions are. Okay, so that's the first step. And so then what's going to happen is you're going to click, the graph that you think. We already said it's going to look like this. So that's good. And so you'll circle it. Okay, fine. Now, step 2 is going to say, all right, or step B, I guess. Step 2 is going to ask you to find 2 points that are on this graph. And then it's going to say, oh, by the way, it can't be the vertex. So other than the vertex. Well, another thing that comes with memorizing these is knowing that the parent function of x, of the absolute value of x, already has a vertex of 0, 0. We already know that. Okay, we have to know that. And so then what's going to happen is we're going to draw this little x and y chart. We're going to throw the vertex in there because we already know it. And we've mentioned several times that when we are trying to find other points, let's pick values that are close to the vertex. So why don't we pick, oh, I don't know, how about +1 and -1? If we had 0, isn't -1 and +1, aren't they right beside 0? Yeah. And so what we're going to do is come down here to our chart. We'll take a 1 and a -1. And then so in order to find these y values, we're going to say, okay, the negative 2 times the absolute value of negative 1, which is going to equal negative 2. The absolute value of 1 is just 1. And when I multiply negative 2 times 1, I get negative 2. And so the point that I'm going to have, the second point that I will have on my graph somewhere, is the point negative 1, negative 2. And then I'm going to do the same exact thing for this little guy right here, just positive 1. I'm going to say, all right, going back up to this function, I'm going to take negative 2. I'm going to take the absolute value of 1, and I'm going to multiply them together. Well, the negative 2 stays the same. The absolute value of 1 is just 1. And so when I multiply, again, I'm going to get negative 2. And so then what's going to happen is, in Hawks, they're going to have a graph waiting for you. They're going to have some blank point values. And here's what you're going to type in. Negative 1, negative 2, and positive 1, negative 2. That's it. And then once you type these guys in right here, the graph will populate itself, and the points will be there. That's all you have to do. So when you see these types of problems, there are 2 steps. The first one is to identify the basic shape of this function. And the second one is to find 2 other points that would be on that graph. Once you do that, you type these little guys in and you are done. What are your thoughts on number 1? Take a minute, think about everything we did, and let me know. We're going to do another one that's similar to this, just to make sure. Okay, so maybe after that you'll have questions. Okay, let's try another one. So number 2, it's very similar to what we've just done. Number 2, we're going to have f of x equals 1/2 absolute value of x. And so letter A, step 1, I suppose, is again, looking at this type of a function, you have to be able to pull out the parent function. And we're going to jot that down real quick. So looking at this, what is our parent function? The
Absolute value.
absolute value of x. And generally speaking, we know that this guy looks like a v. And so we have to come over here real quick and just make sure that nothing's going on out here. That's a nice, neat, positive number. And so that tells me that my function is going to be opening in which direction?
Up.
Yeah. And so now we know that we're just looking for the graph that just has the vertex 0, 0 and looks something like this. And so when you're in Hawks, they're going to give you, again, 4 or 5 to choose from. You're going to find this one. You're going to click it. It's going to say, great job, or something like that. I don't know. And then it's going to say, okay, step 2. I need you to find 2 other points. And again, you're not allowed to use the vertex because technically the vertex has already been found. And so you're going to draw your X and your Y chart. If you want to throw the vertex in there, you totally can. You don't have to. And again, since we're just dealing with the absolute value function, oh, I don't know, let's pick -1, let's pick +1 because they're right beside 0. So let's toss a -1 and let's toss a +1 into this graph. And so over here, we're going to say, all right, well, it's going to be 1/2 times the absolute value of -1. Well, that's going to give me 1/2 times 1. And what is 1/2 times 1? Just 1/2. And so I will put 1/2 in my chart. And then I'm going to do the same exact thing. I'm going to have 1/2 times the absolute value of 1, which is just 1/2 times 1, which is just 1/2. And so I don't know if I can squeeze it in there. Yeah. And so then you're going to have these 2 brand new points that you just calculated. And so in Hawks, you're going to type -1, 1/2. And you're also going to type +1, 1/2. And then this is all you're going to have to enter. And then once you enter that, the points will appear on the graph magically. And then your graph will say, okay, great. And then you'll be done. What do you think?
They always going to have the same Y.
Okay, so this was Sydney, right?
Yeah.
Okay, I'm pretty sure that yesterday you asked me a very similar question, and we had mentioned that if you were picking, like, let me erase this so I can write something. We said that if our vertex was like -4, I don't know, 3, and you were looking for numbers that are close to -4, wouldn't you pick -5 and -3 next?
Yeah.
Yeah, and so we said as long as you pick equidistance, they will have the same value.
Okay.
So, but if you chose 6 and -3, -6 and -3, their values will not be the same. So the answer is yes, just like I answered your question yesterday.
Right.
Okay?
As long as you're doing it.
As long as you're doing it the same distance, yes.
Mhm.
Okay, now, since both of those were, let me
I have a
think.
question.
Oh yeah, go right ahead.
So those 2 examples that we did, is the vertex or the center always going to be 0, 0?
For the parent functions, all 4 of those, the vertex is 0, 0. Yes.
Okay.
Okay, now eventually tomorrow and the day after, when we start moving these things around, the vertex will not always be that, but for today, the vertex is always 0, 0. Okay? All right, now, these are just some random examples that I just now thought of. I'm going to write a couple of things down here real quick, and we're just going to talk about them. You don't even have to write these down if you don't want to. So what if I did this? Let's say that this was your function, and I'm not going to graph anything because I'm making this up on the fly. What's the parent function in this problem?
Quadratic.
Okay, so yes, we can kind of forget the word quadratic. We can just say x squared. That'll be perfect. Okay, but yeah, you're right, quadratic. Okay, how about this one? How about g of x equals -2 square root x plus 3 minus 7? What's the parent function in this guy?
Square root.
Yeah, and so you can see that these things might look a little differently. Okay, last one. How about this? H of x equals, let's say, 3 over x to the third. Oops. Oh, gosh.
Cubic.
Yeah, it's the cubic. Okay, so when we are given all these different types of functions, it's pretty easy for us to pull out the parent function. Do you agree with that?
Are we ever going to have a function where there's more than one parent
No.
function in it?
Nope. There will only ever be one parent function for us to deal with, okay? All right, so now we are ready to talk about a special kind of function, okay? Something that my guess is maybe you've never heard of. I don't know. It is called a piecewise function. Piecewise defined. Has anybody ever heard of what we call a piecewise function?
Yeah.
Oh, some people have. Okay, great. Some people have, some people haven't. That's okay. Okay, so a piecewise function. Here's the definition. It is a function that is defined in terms of two or more formulas. Oops. Comma, each having its own domain, its own unique domain, excuse me. Domain. Okay, let me give you a second to write that down, and then we're going to dive right into example because it's much easier for me to just show you what this looks like than to try to continue to explain to you in words. So a piecewise defined function is a function that is defined in terms, of two or more formulas, each having its own unique domain. All right, now, what's going to happen is when I write this down, if you haven't already looked at the notes or the videos or anything, you're going to be like, oh my gosh, like what is this? Okay, but as always, I promise to break it down and make it much more simple than what it looks, okay? So are we ready to take a look? Anybody have any protests?
Nope.
Okay, here we go. So I think this is example 3. I'm not really sure. But we're going to have r of x equals. Now, here's what's going to happen. I'm going to save a little bit of space. Actually, no, I guess I'm not. I'm going to draw this brace. Okay, don't let the brace scare you. I'm going to have -6x minus 18 if x is less than or equal to -3. I'm also going to have 1/2 x squared if x is greater than -3. This is what a piecewise function looks like when it is presented. Okay, and you're like, oh my gosh, there's so much stuff happening. Oh, that's okay. According to our definition that we just wrote down, we have two or more formulas, which you can clearly see, and each of them have their own domain, which is listed over here. And so the first thing, before we do anything else, okay, we're going to find the domain of these guys because we need to understand that first. So I'm going to do the top one in orange and the bottom one in green, just so you can see the domain. So forget all of this stuff for right now. Oh man, I did not mean to do that. I want you to pretend like for just a second, all we can see, not what I meant to do. Pretend like for just a second, all we can see is this, for just a sec, okay? This says x is less than or equal to -3. So generally speaking, if I were to draw a number line, how would I graph this thing? Where is x less than or equal to -3?
From -3 to -infinity.
Exactly. And so I'm going to write that out in interval notation before I do anything else. So I'm going to say, all right, this little guy is going to happen from -infinity to -3. And I'm going to use a bracket because of this inequality sign. Okay. And so now what I want to do is I want to do the exact same thing to the second one, but I'm going to do in green. maybe. I'm going to do it in green. And so we're going to say, okay, well, what does this say? This says x is greater than -3. So here's -3. And so what is that going to look like? Where is x greater than -3? Well,
3 all the way to infinity.
exactly. And so I'm going to write over here from -3, excuse me, all the way to infinity. So that's going to be the most important thing that you can do to get yourself set up. You need to understand what the domains are so that when we make our graph, it's much easier. Okay. So there's the first thing. The second thing that we're going to have to do is we're going to take a look at each one of these little guys separately. And so we're going to say that this guy is number 1, and we'll do it over here. Okay. According to this, if x is between these two numbers, I'm going to use this function, and I have to graph this. And so what that means is somewhere over here, I'm going to have a graph, okay? And I am going to draw a line. See how this splits the domain? I'm going to draw a dotted line. So 1, 2, 3, 4, 5. Okay, something that looks like this. I'm going to draw a dotted line through the point -3 because here's where my functions are going to change. On this side is going to be my orange function, whatever it happens to look like. And then on this side is going to be my green function, whatever that happens to look like. Our goal is to figure out what they look like, okay? And so in the previous few problems that we've done today, what we have done is we've made an X and a Y chart. And we've picked X values, we've plugged them in, and then we've graphed. And so if you take a look at this domain, we need values that are less than or equal to -3. Well, the first number that's less than or equal to -3 is -3. And then the next number is -4. And then the next number is -5. And that's going to be enough. And so we're going to take these x values and we're going to put them right here. And so we're going to have -6 times -3 minus 18. Now, my advice is to type this straight into your calculator. So -6 times -3 minus 18, that's going to give me the number 0. So I'm going to have the point -3, 0. So I'll graph the points in a minute. And then I'm going to do the same exact thing, but now I'm going to use the -4 that I've picked. So -6 times -4 minus 18. And when I type that into my calculator, I get a 6. And then I'm going to do it one more time, but I'm going to stick the -5 in there. And when I do that, I'm going to get the number 12. And so now on the left-hand side of this purple line, I have these 3 points that I'm going to plot. So let me pause for 1 second, okay? What are your thoughts so far? So far, we're just dealing with the orange line, and we said, here's my domain, and we need some numbers to follow my domain. And we said, all right, well, the first one's -3, the second one's -2, the third one's -5. I took each of those separately. I plugged them into my function. I got these values. What are your thoughts on that? Any questions, any problems so far?
So you don't do like -2 and -4. You go
No.
you go down.
Say it again. I'm sorry. What was it?
So you go like 2 down instead of like 1 before and 1 after.
Okay, so not quite. So let me back up for 1 second. Up here, do you see where each of these domains contain the value -3?
Yeah.
You see how with this orange one we have a bracket, which means we're including -3 in this function.
Okay.
Well, this domain says numbers between -infinity and -3. I can't pick -2 because on a number line, if this is -3, -2 is over here. So the number -2 is not in this guy's domain. So what I'm going to do is I'm going to pick numbers that actually fall inside of this area. So the first one's -3, and then -2, or no, oh my gosh, -3, and then -4, and -5, and -6, and -1 billion, and finally -infinity. Does that clear it up a little bit, maybe?
Yeah.
Okay, so then I'm going to get rid of this work because it's in our way, okay? So then what's going to happen is we're going to come over here to our graph, and we're going to go ahead and plot these 3 points. And so I'm going to plot the point -3, 0. And since up here in my domain, this is a bracket, when I plot that point, it is going to be a closed circle. So I'm going to start at the origin. I'm going to scooch over 3 right here on this purple line, and I'm going to put a closed circle. So got that one taken care of. The next one is going to be -4, 6. And so I'm going to scooch over 4, and I'm going to go up 6, so probably right here, I guess. And then I'm going to have -5, 12. Clearly, I don't have enough space for that, but if I did, it would probably be way up here. Now, the point is, when we look at this, when we just look at this line, since this is just x to the first, since there is no square up there, this is what we call a linear function. This is what we looked at yesterday. We know it's just a straight line. Since this is the slope, and the slope is negative, I know that my straight line on my graph is going to look like this. It's going to be going down. So when I get my points plotted, I'm going to say, all right, well, I'm going to start at 3, 0. this particular line would be looking like this. And even though it looks like that line going up, so to speak, as our eyeballs scan from left to right, as we look from left to right, this line is decreasing, just like we said it should. And so what's going to happen when you're doing this in Hawks, the first thing that they're going to ask you to do is they're going to ask you to pick what the parent function looks like for the first function. And since this is a straight line linear function, you're going to say, oh, it's a line going down. And you're going to look for a graph that looks like this with a line going down. And you're going to find it and you're going to circle it. So let me pause before I do anything else because we're done with this orange. So what do you think? You're going to say, oh, this guy right here, he's a linear equation, a linear function. Since the slope is negative, he's a line with a negative slope. It's a line going down. Can you pick this graph out of a crowd? Sure. It's going to say, okay, great job. So what are your thoughts on that? Any questions, any problems before we continue? All right. So there's orange line done. So now we got to go over here. We got to take a look at the green line. And the green line function is this guy. And so looking at this guy, what's the parent function that we do here?
I'm sorry, but can she please mute? I can't hear you over the rustling.
Okay, I can do that.
I'm sorry.
Oh, no, don't apologize. I can mute people. Give me just 1 second. I think I can. Hey, guys, if you're not muted, do me a favor, mute yourselves. Because it is a little difficult to hear. Thank you. Okay, so, and then if you need to unmute yourself, absolutely. All right, Sophie, do I need to repeat anything, or are you good?
I think I'm okay.
I have a question.
Sure, go right ahead.
I'm confused on the purple.
All right, so let me get back to my purple line here. All right, so do you see, and this is for everyone, not just you, when we first look at this, these guys over here, this is what we call our domain. We talked about domain before. It just says we're going to use this function if the numbers are less than or equal to -3. We're going to use this function if they happen to be greater than. So the first thing that I want to do is I want to draw a line so I show myself where my graph is changing, because I have to graph the two functions on the same graph. And we talked about the vertical line tests. So we have to make sure that when I'm graphing these functions, no part of my graph has the same x value. And so at this purple line right here, this is where the orange function is going to stop and the green function is going to start. So do me a favor, let's graph this. Let's go ahead and graph this green one, and then we'll see if that purple line makes a little bit more sense. And if not,
Is it always going to be vertical?
Yes.
Okay.
Okay. All right, so here we go. So back to my original question that I had asked. This guy right here, what's the parent function?
X squared.
Yes, x squared. And since this is a nice, neat, positive number, what is the graph, the basic graph of this guy going to look like? So we know it's x squared. We know it's positive, and so it's going to be opening in which direction?
Up,
Up. And since it's x squared, which shape is it?
a parabola.
Yeah, so we're going to have some type of a parabola that looks like this. So step 2 in Hawks is going to say, hey, look, I need you to find the basic function of this guy. And you're going to look through all the graphs. You're going to find a graph that looks like this, and you're going to click it. That's going to be the second part. Any questions on picking out this guy right here? Because that's the graph of my parent functions. Any issues with that whatsoever?
I have a quick question for the first one.
Okay.
How I said it was a linear and the line was going down, but why is our line going up?
Okay, that's an excellent question. Now, I'm going to write something, and I don't want you to write it because it's wrong, and I want to show you why. Okay, so let me get rid of a few things here. She wants to know, when we drew this orange line, it kind of looks like it's going up. Well, what if, instead of me stopping right here, what if I would have continued down like this? Would you now agree that that line's going down?
Yeah.
Yeah. Okay, so here's the thing. According to this orange domain right here, our orange line is not allowed to go past -3. So it can't exist over here at -2. It can't exist at -1. It cannot exist any further than what it does. And so because of that, I have to stop right there. And so even though your eyeballs trick you and you think it's going up just because of this little arrow, let me ask you this. What if I took that arrow off? What if I only drew a line that looked like this and I didn't put an arrow? Would you say, hey, that line's going down still, or would you think it's going up?
Up.
Okay. Okay, so get your eyeballs ready. Focus on this red line. Okay, that's the x-axis. If your eyeballs are starting right here and you're looking, as your eyeballs are looking right here, what's happening to this orange line? Isn't it going down?
Yeah.
Yeah. Okay. So what is going to have to happen is when we're drawing all of these lines, we have to train our eyes to focus on the x-axis. And while we are looking at the x-axis, as we read from left to right, this line is coming down. So even though it's going to have this little arrow right here, that does not always mean the line is going up. And if you have to, draw a little bit of a remainder and say, okay, you're going down, but you're actually not allowed to be there. And that might help. Okay. Is that any better whatsoever?
Yeah, that's good.
All right, so let's continue with our green guy. So you've already told me that it was going to be a parabola. It was going to open up where we've picked our graph. Great. Now we have to graph this guy on this graph with our orange line. So again, we're going to pick some x's and we're going to pick some y's. Now we have to pay attention to this domain. According to our green domain over here, this function can only exist from -3, but I cannot include it because this is a parenthesis to positive infinity. And so the first number that's going to be found in this domain is going to actually be -3. But again, I'm only going to be able to use a parenthesis. So let me put a -3 here. Now, looking at my domain for my green one, what's the next number that's going to come after -3? What's the first number that's greater than -3?
-2.
2, and then -1, and then 0, and then 1. Okay, and so then what's going to happen is I'm going to have to take these x values, plug them in right here. And so we're going to use our calculator for sure. And so we're going to plug all this stuff in. And when I do that, I'm going to run out of space here. So when I do that,
How do you know how many points to pick?
okay, so let me draw this first and then I'll answer your question, okay?
Okay.
Because that's an excellent question, because why I picked 3 over here, I picked so many more over here, excellent question. Let me show you visually first, okay? So you're going to take the number 1/2, you're going to plug in a -3, you're going to square the whole thing, and when you do that, you're going to get 4.5, 4.5. I'm okay if you leave it as a decimal because it's easier to count. And then you're going to do 1/2, you're going to plug a -2 and you're going to square it, and that's going to give you +2. And then you're going to take 1/2 and plug a -1 in, you're going to square it, that's going to give you a +1/2. And then when you plug a 0 in there and you square it, it's going to give you 0. And then when you plug a +1 in there and square it, you're going to get 1/2. Okay, I'm out of space. Okay, so here are the numbers that you're going to get when you do all this calculation. And again, you can do all of that calculation right on your calculator. I'm totally fine with that. Okay, now it's time to graph these points, okay? And so the first point that I have to graph is -3, 4.5. Now notice over here at my domain, that's a parenthesis. And so generally speaking, if I were going to put this on a number line, I would have an open circle here. And so when I go to graph this thing on the actual graph, it is also going to have to contain that open circle. So I'm going to go over to the left 3, I'm going to go up 4.5, which is approximately right here, and I'm going to draw an open circle. Now watch this very closely. I'm going to use yellow for just a second. The other day, we talked about the vertical line test, and we said as long as no vertical line passes through 2 points, we're good. Now when I draw this vertical line, technically this little guy right here, he's not included. And since this guy is included, technically speaking, this yellow line is only going through 1 point. And so I'm still in the clear. And so it's very important that we look at our domain and we make sure that when we graph this guy right here is an open circle. All right, now I'm going to graph the point -2, 2. So left 2, up 2. This is a closed circle because he's inside the domain. And then -1, 1/2, and then 0, 0, and then 1, 1/2. Now, Sarah, you asked me, why have I picked so many points? Okay, here's why. Let's pretend for just a second that I didn't pick this last one. Just for a sec, okay? Here's what's going to happen. You guys are going to say, oh, look, this is a line. It's going down. And you're not going to draw a parabola. And so the reason why I ask and I anticipate that we need to put that last point is so that when we go to draw our point, we can see that it is going down. This is supposed to touch. It's going down, but it's the shape of a parabola. And so it's coming back up. Does that answer your question, Sarah?
Should
Yeah,
all
so if it's
of
a formula, you're
the
just going to be cautious and put extra points.
That's fine. You can put as many extra points if you want. You could do 2 and 3 and 4 and so on and so forth. That's totally fine. All right. What was the other question?
yeah, should all of the points be like an open circle or like open dot, or is it just that first point?
It's just the first point. And so if you take a look at our domain, if you come back over here and you look at this value, it's only going to be the point that's listed right here.
Okay.
Because what's going to happen is you cannot have, I'm using purple for a second, so watch. You can't color this in because then what happens? Oh, look, the vertical line passes through 2 dots, and we know that's not allowed. So whatever number is listed over here, when you go to graph, you're going to put your dotted line through that particular number. There's going to be one point that's colored and one point that's open every single time.
Okay.
All right, now after all of this work, we are finally done. And so if this were the test, I feel like a sneeze coming on. So if I sneeze, I apologize. If this were a test, this is what I would expect to see. Okay, this graph, I know it's a little wonky. I need to see both functions on the same graph. So take a few minutes. Okay, look at from where we started and where we ended. What are your thoughts? What's going on? You got to let me know, because otherwise I assume it's all good.
I know it took a while, but can we do another one?
Yes, we can. Okay, I brought one more because I anticipated
you.
that question. Okay, and it won't take as long this time because we kind of know where we're headed. And this was our first one. We had no idea what was about to happen. But before I
I
erase,
think what's confusing me is the domains.
can you be a little bit more specific? What part exactly is confusing you?
Like the parenthesis, negative infinity, comma, -3 bracket. How you know, like, when, because I know we did that a while ago, but I'm just need refreshed on when to
So
include it, when to not include it, when to
okay,
go
so
past
here's
it, when
what
to
I'm gonna do.
stop.
Here's what I'm going to do, okay? I'm going to erase everything, and I'm going to rewrite that, just the beginning, okay? Not the whole problem, obviously, so give me just 1 sec. So let me get rid of this. And so we have a bunch of writing over here, whatever. Here's my domain, okay? This function, and then here was the second domain. And so before we do anything, we're going to pretend like we don't have anything else in the world. All we're going to focus on is our domain. And we're going to say, okay, read this out loud. The first one, it says x is less than or equal to -3. And so on a number line, here's -3. We said if that were true, we would include -3 and we would shade to the left. And if you were to write only this in interval notation, it's from -infinity with a parenthesis to -3 with a bracket. That's how I got that. And then I say, well, pretend like for right now, all we have is this guy. And this says x is greater than -3. And so if I were drawing it on a number line, this would be an open circle and I would shade to the right. And I would say, okay, well, that's from -3 with a parenthesis all the way to infinity. Now, what's going to have to happen is when you're doing one of these piecewise functions, these two guys together are going to have to span the whole entire real numbers section. And so whatever number this is and whatever number this is, they're going to match. One of them has to be a parenthesis and one of them has to be a bracket. That's going to be the case. Let's try another one and see what happens, okay? See if this helps at all. So I have one more for you, and I just have one more. And if you need extra help, I recommend watching a video or talking to me one-on-one later, but I have one more for the class. So we're going to have g of x, and it's going to be set up the exact same way, okay? -5x minus 10 if x is less than or equal to -2, and 2/3 x squared if x is greater than -2. And so here is my problem, okay? And the first thing, again, that we're going to take a look at is we're going to say, all right, here's the domain. Here's the number where the functions are going to split. And so right off the bat, I want to draw this just so I kind of know what's going on. And at the point x is equal to -2, I'm going to draw this dotted line, because I know that right there is where one function is going to be over here and the totally different function is going to be over here. So what are your thoughts so far? All I've done is taken a look at the domain and I've drawn my line. Now, again, I'm going to say, all right, well, if x is less than or equal to -2, that means, so here's my number line, here's -2, less than or equal to, I'm going to include 2 and I'm going to shade all the way to the left. And so that's going to give me -infinity with a parenthesis to -2 with a bracket. Any questions on that first domain? So that's all of this. That's all of these numbers. All right, then I'm going to take a look at the second domain. And again, I will do this in a different color, this guy. This guy right here. And it says x is greater than -2. So if this was my number line, I would put an open circle and I would shade to the right. And I would write that as -2 to infinity. And so my domain for this guy is -2 to infinity. And so that is all of these points.
Are we going to be in a situation where it's y and we have to do a horizontal line?
No.
Okay.
Okay. All right, now step number 1 in Hawks is going to say, hey, step 1, it's going to say, looking at that first function, which is this guy, give me a quick graph of what he looks like. Well, we know that since this is just x to the first power, it's a linear function, so it's a straight line. And if we look at the slope, since it's negative, what does that tell me about my straight line? If this is the graph, what's my straight line going to look like? What's it going to be doing?
Down.
Yeah,
going
it's going to
down.
be going down. So you're going to look for a graph for step 1 that looks like this. You're going to find it, you're going to circle it, you're good to go. Then step 2 is going to say, hey, look at your second function, which of course is this guy, and it's going to say, give me a rough estimate of what that graph is going to look like. And so in this, the parent function is x squared, and generally speaking, we know that is in the shape of a parabola, which is the u, and since this is a positive number, I know it's going to be opening which direction?
Up.
So up, yep. So you're going to find the graph that looks like something like this. You're going to circle it, and it's going to say, okay, great. And then what it's going to ask you to do is it's going to ask you to find the graph of the whole entire thing. And so this is where we are going to have to actually put some points on our graph. And so we will start with the orange one first, just like we did, and we'll find some x's and some y's. And so going up here, we notice that my domain splits at this -2. And we had said that we are always going to put that number in both of our x and y charts. So -2 is going to be first. What's the first number that's less than -2? How about -3? Right? This guy. And then this guy. And then this guy. So -4 and so on. All right, fine. So we're going to take these x values and we're going to pop them in right here. So we're going to have -5 times -2 minus 10. And again, my advice is to put this in your calculator. And so when I do that, I type -5 times -2 and I subtract 10, and it's going to give me the number 0. And then I'm going to do -5. I'll put my -3 in there, minus 10. And when I type all of this in, it's going to give me the number 5.
So do you always start with the point of your domain?
Yes, you absolutely do. Absolutely. Yes.
Okay.
All right, so then I'm going to do the last one, -5 times -4 minus 10. And when I type all of that in, I'm going to get a 10. And so now I have these 3 points over here that I can graph. So before I do that, are there any questions on how I've gotten this far? All right, so then let's graph it. So let me get rid of this junk here in the middle. Get rid of some of these shapes or some of these lines so we can see what we're doing. Okay, so here we go. And so the first point that I'm going to plot is -2, 0. Since this domain is a bracket, that particular point is going to be solid, just like that. And then I'm going to say, okay, I need to graph the point -3, 5. So I'm going to go over 3, I'm going to go up 5. And then the -0.4, 10. So over here somewhere up like this. Okay. And then so we already said that we know that this is a line going down. So we can start here and we can go down. And we have to stop at that point. We cannot go any further. Now, if you want to leave the arrow off, if you don't want to do that, fine, leave the arrow off. You know that that line is actually going down. Okay, we're done with the orange line. Any questions, any problems with that?
So your point's allowed to connect to that dotted line?
It will have to, yes. Remember how earlier I said the domain of each of these guys together is going to span the whole real number system? Well,
Yeah.
orange domain is going to span to right there. And then the green domain is going to start right after this guy with a parenthesis, and he's going to go this way. And so that way my whole entire real number system is accounted for. But on the left-hand side of the yellow line, it's the orange function. And on the right-hand side of the yellow line, it's the green function. But my entire domain is accounted for. All right, let's graph this orange one and see if that helps, okay? So we've already said the graph's gonna look something like this, but we wanna know exactly what. And so we'll pick some X's and some Y's. And again, we're gonna start with this number every time. So we're gonna stick a -2 in there, which is this guy. And we're gonna say, okay, what's the first number that's greater than -2? Well, how about -1? And then how about 0? And then how about 1? And how about, that's good enough. And so then what's gonna happen is we're gonna take 2/3. We're going to stick a -2 in there. We're going to square it. Now, I absolutely suggest that you type this into your calculator. When you do that, you're going to get 2 2/3, which you're, sorry, the dog's barking, which you're going to represent as just 2.67. That's good enough. And then you're going to do 2/3 times -1. You're going to square it. And when you do that, you're going to get 0.67, which is just 2/3. And then you're going to do 0. And when you type that in and square it, you're going to get 0. And then lastly, you're going to do 2/3 times 1. And when you type all that in, you're still going to get 2/3, or which is a 0.67. And so this is 2.67, which is almost 3. This is 0.67, which is almost 1. This is just 0. And of course, this is 0.67, which is also almost 1. Questions on the green work? Okay. So then what has to happen is we have to take these 4 green points that we just plotted, or excuse me, that we just calculated, and we're going to plot them on the exact same graph that we just did. Okay, and now the difference is with this one is when we look at our domain for the green one, we notice that over here it says parenthesis, right here on the -2, it says parenthesis. So when I plot this point, it's going to have to be an open circle. And so I'm going to start at the origin. I'm going to go over 2. I'm going to go up almost 3, which so about right here, I guess. There's my open circle. And then, so I got that guy. So then I'm going to plot -1.67. So I'm going to go over 1, and I'm going to go up almost a full 1 and put a dot. And then I have the point 0, 0. So of course 0, 0. And then I'm going to plot the point 1.67. So I'm going to go right 1 and almost up full 1 again. And so now I can kind of see the parabola taking shape. And so I'm going to draw that, and I'm going to continue that way. And now I'm finished. So I want to erase some of this for just a second so that we can just see the graph, because there's so much writing on this page. So let me get some of this junk out of the way. Oops, didn't mean to get that guy out of there. Okay. And so I want you to just focus on the actual picture for a moment while I get rid of some of this, so that we can say, all right, we get a little bit better of an idea. So this yellow line is continuing up right through the point, the -2. And this orange parabola is continuing up, as is this green line, and they're going on forever. So what are your thoughts? This is my final answer. So what do you think? Okay, because we have to make sure, we have to make sure that this kind of makes sense. Now this takes practice, okay, but it's doable. We just do the same thing over and over. So what are your questions? What are your thoughts? Because those are the only 2 examples that I readied. But if you take a look at the one that we just did, or excuse me, the one that we did just a few minutes ago, and then in this one, they look almost exactly the same. The numbers are off a little bit, but the picture, okay, you can't see me right now, but I'm winking at you. The picture looks the same, okay? So that might help a little bit. They're always going to look the same. I think if you practice a couple of these on your own, you'll get a little bit of a better idea of how exactly to do them. But what are your thoughts? Any burning questions that you want to ask me, or should we move on and see what happens next?
So are we gonna never have like the cubic function and the square root function together?
Not on this, no. It's always going to be, remember I said I'm winking at you? You're always going to have a line that's going down, and you're always going to have a parabola that's opening upward. Okay?
Okay.
I know that's what's going to happen, so I'm just going to tell you. That's what's going to happen. It's going to pretty much look like this every single time. The only difference, this is going to look like this every single time. The only difference is that these little points right here, they might be shifted just a wee bit, but wink, wink, it's going to look like this. Okay? All right, we have one more topic to cover, and it's going to be easier than what we just did. All right, so let's take a stab at it. Let's see what happens, and then I think you'll like this a little bit better, okay? I know that we're past our hour, but I really want to get through these last 2 questions, so if you have to go, fine, go. I'm recording this Zoom video. I will upload it in Blackboard later. But for those of you who are still with me, thank you. We're almost done, okay? So here's what we're going to do next. We are going to do something called evaluating. And this is easier and it's quicker and I like it better. Evaluating our piecewise functions. So instead of having to graph these old things, we're just going to do some evaluating. Okay, so evaluating piecewise functions. Here's what the problem is going to look like. Okay, we're going to have f of x, and we're going to get 2 functions. So -2x squared minus x minus 7 if x is less than -1, or -3x minus 7 if x is greater than 7. Now, just a moment ago, somebody asked me, are we ever going to have like a cube and a square? And I said, no, that's for graphing. When we're evaluating, it's fair game. Who knows what these functions are going to look like? But really, I don't care, because it's going to be so much easier. And so what's going to happen is you're going to have several parts. And the first part is going to say, hey, here's what I need you to do. I need you to find f of 7. And so since we're, hold on, that does not look like a 7. F of 7. Since we are evaluating, what's going to have to happen is I'm going to take this 7, I'm going to replace the x with it. Now I have to look over here at these domains to figure out which function I want. So I'm going to take this 7 in my head, I'm going to say to myself, hey, is the number 7 less than -1? Yes or no? Is the number
No.
No, it's not. So I'm not going to use this one for right now. So then I'm going to say, okay, is the number 7 greater than or equal to 7? And you're going to tell me that it is. And so what's going to happen is, in order for me to evaluate this particular piecewise function, I'm going to take this 7, I'm going to take this 7, and I'm going to put it into this second function, because it's not going to work on that first one. So I'm going to write -3 times 7 minus 7. And I'm just going to evaluate this. And so -3 times 7 gives me -21. And when I minus 7, I'm going to get -28. And now I'm done. That's how easy this particular part is.
So you're basically just taking the number and you're seeing which one it is true for and then just plugging it into that equation.
That is exactly 100% correct.
Where did you get the 7 from to begin with?
It comes as part of the problem. I said, hey, find this for me. The problem will tell you which number. This number right here will be given to you.
Okay.
How easy was that, right? That wasn't bad. All right, well, let's do another one, okay? Because, why not? So
Wait, don't erase it yet.
I will not. Okay, so letter B. So the question is to find f of 4. And so we're going to do the exact same thing. We're going to take this number 4, and we're going to say to ourselves, hey, selves, right? Is the number 4, so I'm up here at this top one, is the number 4 less than -1? Yes or no?
No.
No.
Okay, so it's not going to be the first one. And then I'm going to look at the second one. I'm going to say, okay, is the number 4 greater than or equal to 7? Yes or no?
No.
No.
No. And so what do you think? Am I going to be able to take this particular number and plug it into either one of these?
No.
No.
And so my answer for letter B is undefined. And that can be an answer because I can't. Number 4 doesn't fit to either of those domains, and so I can't plug it into anything. And so it's just not going to work. All right, let's try one more, okay, just to make sure that this makes sense. So letter C for this particular same problem is going to
You're
say,
good to erase if you have to.
that's okay. I think I can fit it. Maybe find f of -5. And so we'll say, all right, well, we're going to take -5 and we're going to ask ourselves, is -5 less than -1?
Yeah.
Yeah. And so I stop right there and I'm going to say, okay, I'm going to put it into this first function. So I'm going to have -2. And instead of an x, I'm going to have -5 squared minus, in parentheses, -5 minus 7. Now, the hard part, and I use that word loosely, the part where you're going to make a mistake is right here. Because you're not going to want to put this double negative, but you have to, okay? And so we're going to square this first. And so -5 squared is a positive 25. And -2 times positive 25 is going to give me -50. When you minus a negative, this becomes plus a positive. So that's going to be plus 5. And then this minus 7 is just hanging out. And so we're going to have -50 plus 5 minus 7. And you're just going to type that in. And when you actually do that, you're going to get -52. And that's it. I'm totally and completely done with this particular piecewise function.
I put the whole thing in my calculator and got -52.
Okay, that's fine. That's totally
Okay.
fine. All right, what are your thoughts on this? This was a piece of cake, right? Easy peasy?
Yeah.
Much easier than the graphing, am I right?
Yes.
All right, now, I want to do one more problem, and I want to scare you a little bit by adding a third function. All right, and then I promise you I'll be done. So let me do that. So the last question for the day, number 6, is going to be f of x equals, and then we're going to have 1/3 x plus 6 if x is less than -5. -2x squared plus 2x if -5, and this is one of those wonky ones that we had a hard time reading back in the day, so we'll talk about that in just a second, or 4x minus 4 if x is greater than or equal to 5. So here are my 3 functions. And I'm going to have, again, 3 values. And I might even give you a minute to work without me. I think I will. So letter A says find f of 5. Letter B says find f of 1. And letter C says find f of -7. So I'll tell you what, take about 2 or 3 minutes. Do this without me, just to prove to me you can. Okay, I'll be here being quiet. If you have a question, ask me. Otherwise, give it a shot, see what happens.
Is that -5 is less than or equal to x?
Yes, it is. So, oh yeah, I forgot to read this to you. So this one up here, guys, it says if x is greater than or equal to -5, or if x is less than 5. So there's 2 pieces to that one. Okay? All right, so do this. I'll give you a minute, and then I'll do it quietly, and then we'll compare our answers, and then we'll be done. All right, if you are done, because some of you maybe, I don't know, here are the answers. So take a look at what I did, take a look at what you did, compare. If you have questions, ask. If you don't have questions, then you got it.
Why would you plug one into the second equation and not the first one? Because technically it works with the first equation.
So okay, so you're asking me why am I not putting one right here?
Yeah.
Is the number one, is this a true statement? Is the number one less than negative 5? Nope. I'm not trying to be a smart aleck. It's hard because you can't see my face. Yeah, I'm never trying to be a jerk. Although sometimes I know when you can't see someone's face, it comes off like that. I apologize. Okay, what else? Anything? I see, 19 of you. I hear like 2 people talking. Are you guys sure? Because I'm done with the notes. This is it. So if you have a question about anything that we covered today, I want you to hang back. If you don't have any questions, then let me just say this real quick before anybody else leaves. Remember, 4.1 Hawks is due tonight. 4.2 Hawks is due tomorrow, as well as the 4.1. Guys, mute yourself for me. Okay, there's a bunch of wrestling. The 4.2 Hawks is due tomorrow night, as is the 4.1/4.2 assignment that's in Blackboard. I need to make sure that you guys are staying on top of your game, okay? I believe me, I'm the world's worst. Okay, I slept till like 11 o'clock today, which I don't typically do. But we got to stay on our game. So anybody need me, hang back. Anyone who doesn't need me, you have a nice day. You message me on Remind if you need anything, and you know what you have to do, okay? So to those of you who are done, I will see you later. And to those of you who stay back, please do so.
Okay,
All right.
I have one question.
Yeah, I'm going to turn my webcam on and also my whiteboard so you can see me and see what I'm writing. All right, go right ahead with your question.
Okay, so for the support assignment 4.1-4.2, the very back of it,
Yeah.
where it has like your written stuff, like how would I find the domain and range? Like I know whether they're a function or not, but like I'm still confused. Like the domain.
So
Is-
let's say that this is one of them. Okay, and again, I'm just making this up. I don't have it right in front of me. So let's say that here's one of the pictures, and I'm gonna draw. Is it? Are you having a problem with like a shape or a line?
like with like a line, like all of it. Like so I know the domain is all the x's and the range is all the y. So like if the point is, let's say, -3, 4, so
Okay.
the domain would be -3 and then the range would be 4.
Yeah, but let's take a look at this particular example because I'm not sure that we're talking about exactly the same thing. So give me 1 sec, okay? So if you're looking at this, when we talk about the domain, we're talking only about the x-axis. And so I want to know how far to the left does this thing go? Well, it goes to this point, which in this case happens to be a -3. Since this is a closed dot, that means the domain is going to be a -3 with a parenthesis. Hold on, let me get
A
this up.
bracket.
Yeah, yes, I'm sorry. I wrote a bracket, I said parenthesis. And then we're going to say, okay, well, how far to the right does this thing go? And it happens to go right here, which the x value here is a 2. But since it's an open circle, I'm going to use 2 with the parenthesis. That's my domain.
So it's not every single point. It's just
Right. That's
okay.
I was confused about what you were saying. Yeah, we're just looking to say, hey, it goes from here to here. We don't have to list out every single point.
Okay, so like if it was like one was a point and the other was an arrow, would the arrow be like infinity then?
Yes, so if that was an arrow, then this would be infinity, absolutely.
Okay, that's all I had a question on.
You want to do the range as well, or are you good?
Yeah, do the range too.
Okay, so we'll do the range in orange. So, or excuse me, green. When we talk about the range, we're only looking at the y values. I don't care about anything else. And so I always want my smallest number to come first. And so what I'm going to do is I'm going to look at this thing. So no more of this yellow nonsense. Don't care about it. So I'm going to look at this and I'm going to say to myself, okay, well, what's the lowest y value? How low does this thing go? And so I'm going to say, well, it goes to right here. And this y value happens to be a -1. But since it's an open circle, it's going to be a -1 with a parenthesis. And I'm going to say, okay, well, how high does this thing go? And this point is supposed to touch that line. This happens to be y is a +3. And since this is a closed dot, it's going to be a 3 with a bracket. And there's my domain and there's my range.
Okay.
Better?
Yes.
Okay. All right, who's next?
I'm having a problem finding like the two on 4.1a, finding the 2 extra points.
Okay, do you have an example right in front of you?
Yeah, so like on Hawks, I had k and then parentheses x equals x squared plus 9x plus 18.
Okay.
And I know you had to do like this completing the square to solve it.
Yeah, to find the vertex, okay.
Yeah, so I found the vertex and it was right. It was like -9 over 2
Okay.
and then -9 over 4.
Okay.
And then, so I tried like a few different like points to try and find it. Like I did -13 over 4 and -7 over 2. And then it said it was wrong. And then I tried -4 and -5.
So the problem that you're having, so I'm making this up. So you're finding the vertex, and you said it was something over something. I don't know. You have the vertex. Were you able to find the x-intercepts relatively easy?
Yeah.
Okay.
I
So
found
the
those easy.
problem. Go ahead. So the problem you're having is finding just the 2 other points, right?
Yeah.
Okay. So watch this. Okay. So here's what we're gonna do. Once you find that once you find the vertex form, you don't really need it again. Okay. So what you're gonna be able to do is you're gonna say, well, what if I just choose, because Hawks is just asking you to find 2 other random points. They don't say it has to be right by the vertex. I said that, right? I said maybe you could do that, but you don't have to. So here's what I would suggest. Pick numbers that are going to be really easy to plug into this. So for example, what if we let x equal 0? So if x equals 0, we're going to put a 0 here and here. And so what's going to happen is I'm going to have 0 squared plus 9 times 0 plus 18, which is going to just give me 18. And again, Hawks doesn't care what you choose. They just need a point. And so you're going to have the point 018. There's 1 point, right? You don't overthink this. I can tell that you're really into this and you're overthinking it way, way, way too much.
Yeah.
Now, what if we just chose, I don't know, how about 1? I don't know. So what if we just let x equals 1? And so we're going to have 1 squared plus 9 times 1 plus 18. Now, these might be a little crazy for us to graph, but Hawks does the graphing for you, right?
Right.
And so you're going to have 1 plus 9 plus 18. Well, let's see, that's going to be what, 28? So you're going to have the point 128. Now, if you were taking a test, first of all, I wouldn't give you those nasty fractions. So you're not going to need those nasty points. This is going to be good enough for Hawks because it just says, hey, find 2 other points. And this is 2 other points.
Okay, so I don't have to find like the ones closest to the vertex, like the x vertex.
If your vertex was a nice, neat, like -1, 3, yeah, sure, then you could pick 0 and -2. That would be fine. But if you have some kind of gross, nasty fraction, just pick some random points that are going to be easy for you to plug into this guy and say, hey, Hawks, this is good enough. Because like I said, when I give you the test, I'm not going to make it so nasty because I'm not trying to kill you guys, okay? Hawks is sometimes nasty. I'm not going to be nasty, okay?
Okay.
Okay. Is that better?
Yeah, I don't think I have any other questions.
Okay. Who else is still here? I see Danae. Is that it? Just you guys? All right. Any other questions though? Because I mean, I'm good if you're good.
I'm good.
Okay. Danae, I don't know if can you hear me? Are you typing anything? Do you need anything? Anybody? All right, Sydney. Well, if you need anything else, if you're working back on 4.1a and you're still having an issue, take a quick pic with your phone and shoot it over to me on Remind, and I'll help you take a look at it. Okay?
Okay, I will. Thank you.
Okay, you're welcome. All right. Bye. All right, Danae, I'm gonna go ahead and leave. If you need something, shoot me a message over on Remind, okay? At least I'm gonna try to leave. Stop share. And